Good morning, everyone. Welcome to the day video of 5 6 CNC workshop on conservation. And today's session will be delivered by Dr. Varthini. She completed her PhD from National Institute of Technology in Singapore. Sorry, it is NAD Priti. I got adapted to senior, so it comes in the flow. She completed her PhD from National Institute of Technology in Singapore and currently working as assistant professor in Government College of Engineering, Singapore. Her area of expertise are risk management, supply chain management, inventory management, logistics, operation management, optimization. She has published more than 10 research articles and 5 book chapters in sources. And she also got Best Teacher Award in Career Movement Institute. And what I could say is she's more of a industry engineer who can complete knowledge on risk management and value analysis and operation technique. And guide us through this session on optimization technique. I expect this lecture will be great thoughtful for all of between students to have a better approach towards their final year project as well because she has a wonderful thought process in optimization techniques as well. Over to you.
Sorry. Good morning, sir.
Yeah. Yes, ma'am.
वो कहाँ है आशीष सर? ये कॉल लगी मॉर्निंग सर। मैंने आपको एक वो टेक्स्ट वो व्हाट्सएप करा है सर आज की मीटिंग। तो मैम आज ऑप्टिमाइजेशन पढ़ाने जा रही हैं तो मिनी टैब वो दिखाने जा रही हैं उसमें सारी चीज़ अनोवा आर एस एम ऑडियो ये सारी। हम्म। चलिए चल इसी की बात करें ना मिनी टैब आगे। आप ये ज्वाइन कर लीजिए, ऑप्टिमाइजेशन आपकी भी काम आएगा। मैं आपको लिंक सेंड करता हूँ मीट पे। क्या किसी का नहीं है? सुनाई तो है, ईयरफोन है ना मेरे पास। जी। अस्सलाम वालेकुम रहमतुल्लाह। आंसर क्वालिटी इशू। Ah, suponho isso seria tipo. Uhum. Uhum. Uhum. Ah, você tem que falar? अब इंटरनेट नहीं चल रहा है। तो आप लिखिए ना डायरेक्टली मीट खोलिए, खुली मीट, उस पर मीट खोलिए, सब छोड़िए, छोड़िए छोड़िए छोड़िए छोड़िए, हमें कुछ नहीं करना, फिर क्लिक तो करिए। मीट खुली नेक्स्ट टैब खुली नेक्स्ट टैब वो जो 9 डॉट्स है मीट पे देखिए। इंस्टेंट नहीं ज्वाइन डिस्क्लोज करिए वो डिस्कनेक्ट करिए कॉल एंड फॉर एवरीवन देखिए रिटर्न एंटर द कोड एंटर द कोड लिखिए EXN ना कुछ भी EXN समान में HZRAYZE हेलो एनेबल पे क्लिक करिए एनेबल पे टिक करिए एनेबल पे ऊपर ये जो टिक लगा है ना ऊपर हाँ हटाइए ओके आस्क टू ज्वाइन मैक्सिमाइज Hello.
In this solution space, somewhere I have an optimal solution that is best maximized MR. So I want to find this solution. So how I am going to search this space? Okay, for that only we are proposing the meta heuristics. I might start from here. So at this point, my solution will be very, very inferior. Okay, then I will move to another point. So like that, I will be searching this entire space till I will reach a better solution. Okay, so that's how we are evolving. So under this you'll be having genetic algorithm. So initially we were weaker species. Depending upon our environment, we are actually adapting, or you can go with immune algorithm that is actually more suitable for the current scenario. So during the first phase of COVID attack, we were actually there was a huge amount of death rate. But as the phase move on, we are actually developing an immune. So we are actually giving a better solution. So depending upon depending upon the evolution of immunity, also we can develop a meta heuristics. So meta heuristics is completely an algorithm that is developed based on the behavior of population. Okay, we'll see that in detail. Any doubts till now?
No, ma'am.
Okay, right. So now let me depict a flow path of what we are going to see.
23.
So when you are going to perform a mathematical modeling and optimization, the first thing is you have to choose what are the inputs you are going to study and what are the levels of input. Okay, this is the first step you have to do. So you can do this using any literature review, or depending upon the type of machine you have. As I was saying in my previous example, speed is one input. When I say level, I can say, so it starts from 200, the second level might be 1000, and finally I was saying 3000, right? So I can take three levels like this, or I can take only two levels as in 200 and 3000, or I can take five levels. Okay, so more the number of levels you're going to take, more the number of experiments you have to perform. Okay, so as you know, performing an experiment is not a cheap work, because it will be very expensive. So if you use a wire EDM in a CNC setup, it costs around 2000 rupees to work for 1 hour. Okay, so depending upon the number of levels, the time will also increase. So the first step is you have to choose what are the inputs that you want to study, and depending on the literature review, you can choose, or the capacity of the machine, you can choose your level. So once the inputs are ready, this is your first step. The second step is I'm going to design the experiment. That is, for what combination of speed, speed and depth of cut I am going to perform the experiment. Okay, so this will be done. So once you develop this experimental setup, then you can perform the experiment and measure your output. Say for example, I am measuring the MRR. So initially, say for example, I had a speed of 200, speed of zero point 0.1, depth of zero point 0.1. So for this combination, what is the material removal rate? So measure your output. Once you measure your output, the next thing is you have to perform a statistical analysis. So this statistical analysis will tell you which input factor has better influence on the output, or which combination of input factors, this is known as the interaction effect, which combination of input factors has a significant influence on the output. So why it is important to find this? Okay, once you find the significant factor, you can actually conveniently model your problem in such a way by only changing your that particular input factor. Okay, remaining other factors you can ignore it. Okay,
इनका
so once
लेक्चर
you
खत्म होने
perform the
वाला है
statistical analysis and determine the significant
यार तुम
factors,
आज डेट बता
then
दो
you can do
फिर से
response surface methodology.
फिर
This
क्या
is
लो
nothing but a prediction model. Okay, so why I'm preparing this
तो
is,
वैसे
this is
ये
my
ना आपको
output.
कहना
Why
पड़ेगा
is my
मैंने वीडियो
output?
शुरू करी
Which is a function of my input parameters. Okay, so I'll be getting an equation, right? So this, as of any equation, it will be having a coefficient, then a constant x1 plus x2 plus x3, right? So for whatever combination of speed and feed depth of cut which I give, I can predict what is going to be my output without
और
performing the
आफ्टरनून
experiment.
में कितने सेशन है
Okay,
दो
so once I have this prediction model, I can finally optimize.
तुमने कंटेंट क्या क्या कंटेंट
Okay, so that I can find out for what combination of speed,
बच पे
feed and
तल
depth
वाला
of
वुशान
cut I can get a maximum MRR.
मसला छुनु सो
Okay, I'll give you
मसला
an
कुछ कुछ
example. So you have performed an experiment using only these three levels. So
लेकिन
your
दोन घंटा मुझे
experimental
मशीन
value will have only 200 RPM or 3000 RPM or 1000
कितने
RPM,
बजे तक एक
right?
घंटा है ना
This is what your experience will contain.
1.5 घंटा बहुत
But
ज्यादा है उसके लिए
your maximum MRR will be
आधा घंटा
achieved
उसके लिए
when
ठीक
your
है
speed is 350. Okay, so this 350 value is not taken in the
वो चीज वन नहीं
levels. Okay, so
हाँ
only when you
हाँ
optimize,
बचोस
you
नाट
can
कॉलेज
find out between the lower limit and the
हाँ
upper
सर वो
limit
ना
which
सर वाइस
value
ब्रांड
is
है
going to
ना
give
वो
you the
होल्डर है
most maximum MRR. So for that we have to perform a optimization. So this is what we are going to do now. Can you get the flow part? Any doubt in it?
इंसास अंकार नकार करा मज मज अंकार नकार एम के तो डाउट
Oh, you can proceed. Yeah.
Okay. So assume that you have
इंसास क्या बोला
chosen your input, you have chosen the levels and everything. Now we'll
ऑडियो
see
दस्ते बन
what is
गया
design of
हाँ
experiment,
सेटिंग
how
कर
to have a suitable
बैठो
combination
दास
of
कोडिंग
inputs and perform the experiment. Okay. As I was saying, performing a huge
चेंज
number of
कर कैसे
experiment
बस
is actually very time consuming and it
किसे
also
तगा
very costly.
अपने विचेस बना
So
कोडिंग
here what we are going to do is we are going to have a planned matrix of independent variable. Okay, so I'm going to plan what value of speed and what value of feed and what value of depth of cut should be given in experiment number 1. Okay, so this is a statistically planned matrix of independent variable settings. Okay, once you plan it, then only you can perform the experiment and get the output. So why we are doing this? It is to
उससे क्या
find out
पूछना
what is the
काउंट
optimum level
कंट्रोल
of
सिलेक्ट
independent
कंट्रोल
variable. Okay,
स्पेसिफिक
so
ये
for what combination of independent variable, you are going to get a
ये होवन
maximum
ना
or a
पतन कर
minimum
पट
output
एसकिट करें
function.
जो 5 एक्सिस
And
में
you are also
एक्सिस
going to
पतन
find out
टाइम
which are the
बचावन किट कर तमिस
significantly or
तम कर
crucially
ऑपरेशन से
important
अत
independent
को ना 3
variable,
एक्सिस पैटर्न तत लोग आ
and you can
घंटे
also
30 मिनट गाइले इसे हो
you
करूँ
can
जो
also
3 एक्सिस
eliminate
पैटर्न
the
तब नहीं जाए
minor or insignificant independent variable. You can predict the output function for a different combination of independent variable, that is whatever we have not done in experiment. So whatever value you give, you should be able to predict. And it was also used to identify and reduce the noises, that is the uncontrollable factors. Right. So how many experiments should be done for a particular experiment? We will see that. Okay. Suppose you're having say for example yeah, k number of input factors. Like in your previous case, we had 3 input factors, right? So you have k number of input factors, and each input factor has 2 levels. Then you actually have to perform 2 part 3, that is 8 experiments to completely analyze the effect of all the independent variable. Okay, that is known as factorial design. Okay, let me give another example. Suppose you have 5 factors and each factor has 3 levels. Then how many experiments should you should perform? 5 factors and 3 levels. So the level should come down, that is 3 power 5. Okay, only when you perform all these 3 power 5 experiments, you can completely understand what is the effect of each and every factor, as well as the combination of factors. Right? Okay, so in the both the example I told, each factor will have a same number of level. Suppose you have k factors with each factor having different levels. Say for example here, so I have a factor and levels. Okay, so I actually have 5 factors. Okay, the first factor has 2 levels, and the factor 2 and 3 has 3 levels, and the factor 4 has 1 level. 4 has 1 level. Okay, then the full factorial design can be determined using the same formula. So you have 2 levels, right? 2 level 2 power 1, because you have one factor having 2 levels. Next is the factor 2 and 3 is having 3 levels, right? So 3 power 1 and 2, 2. Then the fourth factor is having, sorry, then the last factor, fourth factor is having only 1 level, so 4 power 1. Okay, so this is how you determine how many experiments has to be performed in an experiment. Okay, 1 second, I think I'm making a mistake. Let me repeat it again. Okay, so totally there are 2, 3, 4, only 4 factors. 1 second. So factors and levels. Okay, so we have one factor which has 2 levels, and factor 2 and 3 has 3 levels, and the fourth factor has 4 levels. Okay, so the level 2 is having only one factor, and 3 levels is having 1 and 2 factors, and there is a factor which is having 4 levels. So one factor is having 4 levels. Do you get how to do this? Am I understandable, guys?
Yes, ma'am.
Okay, so here you have an explanation. So one factor has 2 levels. One factor 1 has 2 levels. Then 2 factors has 3 levels. That is factor 2 and 3 has 3 levels. And the last factor, it has 4 levels. So totally we have to perform 72 experiments to get your inferences, right? So if you perform all these experiments, then it is known as full factorial design. That is, I'm going to perform all my 72 designs, 72 trials. So that is going to be known as full factorial design. But in most cases, performing 72 experiments is actually very, very costly and time consuming. In such case, we'll be using fractional factors, where I will be either performing only half of the experiments or one fourth of the
मैम ये
experiments.
ऑप्टिमाइजेशन
So
नोट
that is
करके
actually
रखिए,
the concept.
क्योंकि ये आपके काम आने
Okay,
वाला है।
I'll show you in
जब आप
demonstration.
एक्सपेरिमेंटेशन स्टार्ट करेंगी तो ये
Right.
आपके भी काम आएगा।
Let me share my entire
जी
screen.
सर। थ्री डिशेस ने मिशु मगर मिशु yapari inşallah. Şu Zahid Zahid ne? Bir yapalım. İki. Şunu चलाना सी मीटिंग तो
Is
तो
my
ये
entire screen visible?
No, ma'am.
Give me a minute.
Herken एक जो है इसका।
Is it visible now?
नो मैडम।
Is my screen visible now?
No, ma'am.
Okay. Wait, there's an error. What about now?
Yes, ma'am.
Yes, ma'am.
Okay, we'll start with an example. So here, actually this is a wire EDM operation. So there are totally 6 factors. Okay, so we have 6 input factors, and each input factor has different levels. Say for example, the first one is the taper angle. It has 2 levels, 3 and 1.5. Whereas peak current, it has 3 levels. Remaining all other factors has 3 levels. Now, can you tell me how many experiments should be done if your design is going to be a full factorial design?
कितने
Okay.
फैक्टर्स हैं? 3
So
4
remember the formula,
6 फैक्टर्स
the
हैं।
number of levels to the power of number of factors. This is how you do the formula. So how many levels are there in the first factor?
एक
There are
इसके 2 लेवल्स
two
हैं,
levels, and in remaining all other factors there are
3 लेवल्स हो
3 levels.
5
So now tell me how many experiments should be performed? One factor has 2 levels,
2 9 4
and
27
remaining,
9
come on guys,
81 81
remaining, how many factors has 3 levels?
5.
That's
5
it. Okay. So you have one factor having 2 levels and 5 factors having 3 levels. So what is the answer?
They have typed somewhere in chat box, I think.
Okay. So can you tell me what is the answer being typed out?
486, ma'am.
Thank you. 486. So just imagine the significance of this. We have to do 486 trials to get out what is the most influencing factors and what is the interaction effect is going to be. So doing that will be very, very difficult. So in order to overcome this disadvantage of full factorial design, Takuchi actually proposed a orthogonal array of design where we will be performing reduced number of experiments, but with that reduced experiments we are
बहुत
still going to
राइट
able to
बंद
perform the
करना
statistical analysis. Okay, so I
सेंड
will show you that with an example of this problem.
अच्छा जी जी वापस
Okay, for that I'll move on to the Minitab. So Minitab is actually a licensed version, but you can have a free trial of 30 days. So I suggest you to perform this example and try out and see how it works. Okay, so let me create a new project.
तो आप फिलहाल देख लीजिए ना। जो पेन ड्राइव
Okay, so this is how the screen will look like. So first thing is I'm going to create a full factorial design. I want to show you how a full factorial design will look like. Okay, for that first click on the stat. Okay, so whatever we are doing, that's like the statistical analysis. Okay, so go under DOE, click on factorial and click on create
Create
factorial
factorial
design.
design.
Okay, let me repeat
इस
again.
तरीके से
So move over, start, DOE, factorial and
हेल्प
create factorial design.
डेवलपमेंट
So click on that.
हाँ
So you can see that
किसी
for
ऑफिस में
different
करते
levels and different factors,
हैं
you can see what are the designs available.
से वाइट आराम से
Okay,
कुछ कम
so
करो थ्रेशोल्ड
in
करो
our problem we have 6 factors, right? And one factor is having 2 levels and remaining
सेंट्रो
factors is having 3 levels. Let me go back. Yeah. The total number of factors is 6. Okay, and let me see what are the designs available. Okay, so if you are going to perform a full factorial design, yeah, first I have to choose the levels. Okay, so this is not a 2 level factorial, so I'm going to go with general full factorial design. Okay, so let me see what are the designs available. Before that, you can specify the number of levels also. So in fact, in factor A, sorry, so in factor A, we have 2 levels. So let me write 2. Okay. Whereas in factor B, we have 3 levels. Okay. So given out of 6 factors, only factor 1 is having 2 levels and remaining all other factors having 3 levels. Replicate is, what do you mean by replicate is, if you want to perform the same experiment more than one time, because as we are saying there will be some uncontrollable noise factors. In order to nullify that, you will be actually replicating the designs. Okay, so will have only one. Okay, I'm clicking OK. Right, now let us see what are the designs available. Yeah. Okay, so I'm not so this is the name of the factor. So here you can provide a name. The name is taper angle. So I can type the name taper angle, or either I can simply leave as it is. Okay. I can also mention whether it is going to be a numerical value or a text. So where we'll be using text is, suppose your input parameter is the type of coolant you're going to use. Okay, you can either use a oil-based coolant or a water-based coolant. Okay, so in such case you can change it to text. Whereas in this case, I'm going to mention it as level. Okay, so you can specify the value. Okay, so because of time constraint, I'm not specifying the value. So if you want to specify, the value will be uh, 3 and 1.5, right? So the value will be 3 and 1.5. So like this, you can mention the levels. If you don't want to mention the value of the levels, you can leave as it is. Okay, I'm doing that. Everything back. Okay, and then I'm clicking OK. Okay. Yeah. So I've given the number of factors, and then I have given the what are the levels of each factor, right? Then I'm clicking OK. Okay. Since I'm going to create a factorial design, so how many trials do you expect? How many number of experiments do you expect to be run here?
486
How many number of experiments you'll be doing? You'll be doing,
486
guys, is my screen visible?
486.
Yeah, you'll be doing 486 experiment. So this is your, we'll delete these because it'll be confusing. So this is your combination. So the first experiment, your input parameter A will be at level 2, the input parameter B will be at level 3, and the input parameter C will be at level 1. So this is your first set of experiment. So by performing this experiment, you have to determine what is going to be your output. Okay, so I have not mentioned the value of 1, 2, 3. But if you have mentioned the value, so 2. So what is the value of 2 in case of A? Level 2 is 1.5. Okay, so if I scroll down, you can see there are totally 486 experiments that are to be performed. So totally 486 experiments. So this standard order is it's actually randomizing the trial. Okay, so that is so this is how the full factorial design will look like. So as I was saying, full factorial design is highly time consuming, so it is very very difficult to perform it. Okay, hence we are going to move on with the Takuchi method.
समझ आया
So let
ताकुची
us see
कैसे
how
काम
to do
करना
that.
है?
So I'm
अदरवाइज
creating a
आपको
new worksheet.
486 एक्सपेरिमेंट करनी
So
थी।
same procedure, stat, DOE, Takuchi, create Takuchi design. Okay, let me repeat again. Stat, DOE, Takuchi, and create Takuchi design. Let me click on that. So in our problem, we have a mixed level. That is, we don't have all the factors with same level. So we are going to choose mixed level. Okay. So mixed level means I can say that say one factor is having two level, three factors having four levels, etc. Okay. Now tell me how many number of factors are there?
6.
Thank you. Six factors. So let us see what are the designs that are available. Okay. So this column, this indicates the factors and levels indicates the different combinations. Okay. So you have to choose L16 design. That is, you have to perform 16 trial if you have five factors having two levels and one factor having four level. Okay, let me repeat again. You have to perform 16 trials if in your experiments you have 5 input parameters having 2 levels and 1 input parameter having 4 levels. Okay, can you tell me which combination I should use?
1 of 2, 5 of 3,
In our
L18,
problem, I have
L18
one factor having
वही है ना?
2 levels and
L18
5
है ना पहला
factor
वाला?
having 3 levels.
5 factors
So
of
tell
3
me
level
which
and 1
design
factor of
I
2
should
level.
choose.
L18 है सर, L16 के बाद 10 थोड़ी ना आएगा।
L18.
Very good. That too,
हाँ
the second one, because L18 is
ये
the
है ना?
correct answer. So we have to perform 18 experiments. So because we have one factor having two levels, the factor A has two levels, and remaining five factors has three levels. Okay. So now can you imagine from 486 experiments, we are actually come down to 18 experiments. So performing these 18 experiments is enough to
18
find out
18
or the statistical
भाई
analysis.
साहब।
Okay. So I'm going to do this. So I'm going to create L18 design. Okay. In the same way, I can specify the name. I can give a taper angle. I can give value. Okay, I'll show you for first one. You can type the taper angle. So this will be the first level is 1.5 and the second level is 3. So like this I can type. Okay, so that the design is complete, or I can simply leave as it is, because I know what is the value of first level and what is the value of second level. Okay, I can simply leave as it is. Okay. Yeah. Okay. Click OK. See? So this is my L18 design. Okay. So in my first experiment, I'm going to choose first level of A, first level of B, first level of C, first level of D, etc. And I'm going to perform the experiment and determine what is going to be my material removal rate. I'm going to perform this operation. Okay, so can you now imagine how from 486 design using Takuchi's method I actually brought down the design to only 18 trials. Okay, so depending upon your number of inputs and number of factors, you have to choose a design. You cannot randomly get a design. Okay, we'll do one more example so that
कंप्लीट हो गई जल्दी करिए ज्वाइन
you
करिए
can
ज्वाइन
get it
करिए
more
जल्दी
clear. Yeah, so this is the problem which we are
मैंने
going
पूछा
to deal with throughout this session. So let me type this. So I have 1, 2, 3, 4. I have 4 factors, and in these 4 factors, all are having 5 levels. Okay, so now you have to tell me how to do it. Okay, I'm going to do with Takuchi. Start, DOE, Takuchi, create Takuchi design. So let me show the problem.
क्यों नहीं जी?
So I have 5 factors. I'm sorry, I have 4 factors and all the four factors have 5 levels. Now you have to tell me what option to be choose.
5 factors. अरे यहाँ पे
Come
High
on,
level design.
5 level
very
design
good.
for
This is a
4.
5 level design.
Number of factors for
Then
4 है ना? हाँ.
4.
number of factor is 4.
क्या हुआ?
Is it boring? Guys, because
No,
at the
ma'am.
end of your thesis, you have to do result and analysis. At that point, all these will look like Greek and Latin. So I think it would be very, very useful to you if you guys be more interactive and listen to this. Okay. So let us see what is the correct design. Okay. So since we have same level instead of mixed level, so there is only one particular combination. So I have 4 factors and each factor has 5 levels. So totally I have to perform 25 experiments. Okay. So in this case, I'm going to write down the names because I'm going to perform it completely. So peak current duration. Okay, let me give small form. Peak current, pulse duration, duty cycle, pulse duration, duty cycle, power concentration, powder concentration. I think this is something related to material metallurgy process powder. Okay. So let me specify the constants also 5, 10, 15, 20, 25. Okay, so simply type it 5 space 10, 15, 20, 25. Then
मीट खोली जल्दी.
5, 10, 20, 50, 100. 5, 10, 20, 50, 100. 8, 6, 24, 32, 40. 8, 6, 24,
816.
8, 16, 24, 32, 40. Okay, so these levels generally will be taken based on the literature review 02468. 02468. Okay, I think I covered it. Or we could just simply.
लेवल. अच्छा.
It's just a paper from which I'm taking the problem, so let me open that.
मल्टी ऑब्जेक्टिव ऑप्टिमाइजेशन वर्ड है. सब.
Okay, so my levels are 5, 10, 15, 20, 25, 5, 10, 20, 50, 100, 8, 16, 24, 32, see left out, 32, 40, 02468. Right. Okay, that's it. So this is the 25 trials which I have to perform. You look at your paper.
इंटरेस्टिंग.
See, so they have done these 25 trials. Okay, and they also measured two outputs: surface micro hardness and surface roughness. So what is this R1 and R2, R3? Can anyone guess? What is this R1, R2, R3?
Replicas.
Okay, so these are the repetitions. So I am performing the same experiment 3 times so that I get the three different values. Okay, so the same set I'm performing it for 3 times.
शाबाश स्किप करो वन करो स्किप
Okay,
तब पूछो पूछो
now let us perform the statistical analysis. Okay, go back to the content. So this is how your experiment will be designed. So now I've performed the experiments. I've measured the surface micro hardness and surface roughness. So each trial I have measured it 3 times. That is what R1, R2 and R3 are about. Okay. Uh, there is another term known as S by N ratio. I will tell you
सिग्नल टू
what that
नॉइज
is
रेशियो
and how to find it.
सिग्नल टू
Okay.
नॉइज
So let us do that. So
यस
I've created the Takuchi design. Let me copy the values. One second.
डबल डॉट पे क्लिक करिए डबल डॉट यहाँ पे राइट साइड में नीचे डबल डॉट चेंज लेआउट सेकंड वाला ऑप्शन स्पॉटलाइट हाँ जी सर प्रेस कीजिए डबल डॉट टू सेकेंड यहाँ पे आइए हाँ ये एरो वाला हाँ अब उनको वही चीज़ बता दीजिए शाबाश कैसा कोई नहीं थे वही करो सी फाइल स्किप श्रीनगर पावर पॉइंट नॉट रिस्पॉन्डिंग चलेगा
So my system is lagging because I opened all three softwares.
मिनी टैब बंद कर लो ना मैडम जी मिनी ट्यूब चलाने की क्या जरूरत है वालेकुम सलाम ये तो वैसे यूनिवर्सिटी में बंद कर रखी है जब ये सिस्टम
So
नॉट
these are the three replicated outputs of micro hardness.
मैं बोल स्किप
This is replication 1.
स्किप
Okay. So now we have the set of inputs. We have performed the experiment and we have also measured the output. Now we'll see how to do the statistical analysis. Since we are doing Takuchi, I'm going to Takuchi. So we have created. I'll tell you when to use this define option. Now
मैं
let us
आपको बताऊंगा
analyze
ट्रेन
the
करने के लिए
design.
ऑप्टिमाइजेशन सिखा रहे हैं
Okay.
फालतू क्यों
So if you click the analyze option, you'll be getting a dialog box. So click on the replicates. Okay, only one response can be analyzed at a time using Takuchi design. Since we have three replicates, I'm going to choose all those three.
Do all.
Okay, so
Do
graph.
specific tick.
So I can plot the signal to noise ratio, mean plot, and infraction plot, and all.
Some
Guys,
more
am I
minutes.
audible?
ठीक ठीक ठीक ठीक ठीक.
Yes, ma'am.
Okay.
Yes,
So
ma'am.
analysis, I'm going to analyze the signal to noise ratio and means. I'll come back to you what I mean by signal to noise ratio.
Stop, ma'am.
Put it over. Aisha.
The terms is I'm going to analyze the only the main effect, that is only the input effects A, B, C, D. If I want to analyze the interaction effect, that is A and B, the combination of both, I can include in this particular tab. Okay, I'll do that later. So as of now, I'm going to analyze only the main effects. Okay, so I have going to get some plots. I'll tell you those. Yeah. So signal to noise ratio is, since Takuchi is an electrical engineer, he termed the output to be signal. Okay, so you are going to find out what is the output divided by the noise, that is the uncontrollable factors. Okay, so I'm going to, instead of just finding out the output, I'm actually going to find output divided by the noise ratio. Okay, so my objective here will be always to increase the signal. Okay, when I'm just imagine I'm attending a call. I want my signal to be better and I want to nullify my noise. So this noise to signal ratio should always be high. Okay, but here we have some four options. Larger is better, nominal is best, and smaller is better. Okay, why we have these four options is our output should be either maximized or minimized. Okay, remember the signal to noise ratio should always be high, but our output can be either maximum or minimum. Okay, so in this example we are actually studying about surface micro hardness. So can anyone tell me whether it should be maximized or minimized?
Maximize. Maximize.
Hardness should be maximized or minimized?
Minimum.
Hardness should be maximum. Okay, better the hardness, it will be, the quality will be good. So I'm going to choose larger is better.
Use करना
Suppose if you want to if your output is say surface roughness, then you will be
But this
choosing smaller is
okay
better.
उसमें
Okay, so here
flexibility
I'm
बढ़ाना
choosing
चाह रहे
larger is
हैं
better.
कम
So the formula is given, so this is how we are going to determine it,
आज
but
वो इतनी कम flexibility होगी ना
you don't have to do it manually, you can simply get the
indentation
value.
के लिए है ना
Okay, clicking OK.
flexibility तो elastic
So now the graphs as well as the statistical
hardness क्या
analysis
होगा
will be performed.
sweetness
Okay, I will tell you what each graph indicates. Okay, first let us see about this graph. So this is the residual plot for means. Okay, so what residual actually means is the error. Okay, so you have actually developed a model that is going to predict your output for the given set of input. So this is your prediction linear model. Okay, these red dots represents the error. So this is your actual experimental value. So this is your predicted value. So this difference is nothing but your error. Okay, let me repeat again. The blue line is your prediction value, predicted value, and this red dots is your actual experimental data. Okay, so since the experimental data is closely fitting the line, it means your model is good. Okay, the next one is residual versus fitted value. Okay, so this is your fitted value, that is 0. So this is actually the predicted value. So predicted value will be having a 0 error. Okay, whereas this is your experimental data. So this experimental data's residual should not be grouped together, it should be randomly distributed in the top and the bottom portion of the zeroth line. Okay, then only you can say your model is good. Similarly, when I plot a histogram, this is 0 is your error, right? So whatever residual you are getting from this prediction model, the residual should be either the negative and it should also be positive. So when I plot a histogram, it should be following a normal distribution. Then only we can say your model is good. Okay, also when you observe the residual in the experimental run, so this is the residual for the first run, This is a residual for the second run. This is the error for the third run. So when you plot it, it should not have any pattern. It should be randomly spread out. Okay, so if this error, if these four graphs satisfies these, then you can say your model is good. Okay, then you can move on with the inferences, right? I will tell you what are those. First, let us see this one. Yeah. Okay, I didn't. One second. I'll close off the remaining things. Let me copy it again. Yes. So it is already there. The signal to noise ratio is missing. So let me reanalyze because I forgot to click on the storage tab. It should store the signal to noise ratio. Okay. Okay. Okay. Yeah. So this is your signal to noise ratio which has been determined. So since I have given the larger the better, then you will be using this formula which I have shown here. So larger the better means you will be using this formula to determine the signal to noise ratio. Always remember, depending upon your objective function, you have to choose larger the better or smaller the better. But this noise to signal ratio, it should be always high. Only when this is high, it means the effect of the noise has been nullified. Okay, so this is shown here. So let us move on to the analysis part. Yeah. So if you look at it here, you will be having ANOVA table for the means, that is the average of the output, and also the ANOVA table for signal to noise ratio. You can interpret both. Okay, nothing wrong with that. So if you check on here, when I check on the means, the first thing you have to see is the p value. If the p value is less than 0.005, okay, because your confidence level is actually 5%. If this p value is less than 0.005, then the input parameters are significant. As you can see from here, okay, all the four factors is having a p value equal to 0. Okay, in such case, all these four factors have a significant effect on the output, which is your surface, which is here the micro hardness. Okay. Similarly, if you consider for the larger the better, there also we will be having a, I think it will be in the top, ANOVA table. Okay. Here also the p value is all less than 0.005. It means all these four factors have a significant effect on the output. Okay. So here actually a linear model is being proposed. I'll talk about that later. So in this case of ANOVA table, you can infer two things. One is what are the significant factors that is going to affect your output. The second thing is how much contribution each input factor is going to give on your output. Okay. So here the value of the pulse current, this is a sequential sum of square. I'm not going to tell you how to calculate those and all. Here the sequential sum of square is 19.62. So I want to know what is the percentage of contribution of this pulse current factor on the micro hardness. So how I determine this, I will be dividing this 19.62 with the total value, that is 51.908687. So if I divide that, I can determine what is the contribution of the input pulse current on the
ये जबरदस्त
micro hardness. Okay, let me compare our value with the experimental value. So S-band ratio is 19.62. Yeah, I'm getting around, here they got 19.53. So they have divided this 19.53 by the total value 51.72. Okay, then you will be getting 0.377. So when you convert it to percentage, that will be 37.77 percentage. So what it actually means is this input factor, it has around 37 percentage influence on the output. So compared to other factor, this factor is having the maximum influence. So this can be inferred from the ANOVA table. Okay. So below that you can see there's another thing, delta and rank. Okay. So what you mean by rank here is, this is actually ranking which factor is having more influence on the output factor. So the first rank is got by the pulse current. The second factor is powder. So if you compare here, you can see it. So this is for, one second. This is for signal to noise ratio, right? Yeah, the second factor is for the powder. The third one is for pulse duty, and the fourth one is the third parameter. So using this analysis, you can do three things. The first one is you can find whether a particular factor is having any influence or not. The second thing is you can find out the percentage of contribution, and the third thing is you can rank it. Okay, so all these can be done by first finding whether the model that has been
मैं
developed
क्या
is
कह लिया
accurate or not. So
क्या
how to
है
find that? Your R square, this is known as coefficient of
अब उसका
determination.
बस इसके
Your
समझ
R square
लिए
should be
सारे
always
perspective
greater than 85%. Only if it is more than 85%, you can say your
बिल्कुल
model is
ये
good.
जाहिर शर्मा को होना विरोध
Okay,
अच्छा चल साले
so this is what we got. Any doubt in it? So we can actually rank it, rank the factors, and we can find out whether the
दिमाग नजर कैसे कर रहा है
interact, we can also find out the percentage of contribution. Okay, so now
Ma'am,
let me show you another example.
ma'am, one doubt, ma'am.
Yeah, tell me.
Ma'am, if R square is greater than 90 and R square adjacent is less than 90, like 80, 70, like that, shall we
No
accept it?
problem. No problem. Because
Okay.
R square adjustant will be considering the standard deviation also. Okay, this is
Oh,
standard deviation. If R square is greater than 85 percentage, well and good, you can proceed with your analysis.
okay, ma'am.
Okay,
Thank
R
you.
square adjusted is not important.
Okay, ma'am.
Okay, so I've taken another example, actually the previous one which you have done. So this is
पॉइंट
the
पता नहीं
ANOVA
जो
table which I got.
लड़की ने पूछा
Can you tell me which is the significant factor here?
अगर भाई साहब
The
इससे
same
कम होगा ना
confidence level
85
of
तब हालत खराब हो
5% has
जाएगी
been taken. Can you tell me which is the significant
मतलब ऐसे
factor
एक्सपेरिमेंट कर रहे
among A, B, C, D, E, and F?
थे 85 से जाना आना चाहिए वही तो लोचा है इसमें आना चाहिए
I told
फिर
you
से कम
when
हुआ
the
तो
p
एक्सपेरिमेंट
value
खत्म
is
दोबारा से करने
less than 0.005, then that particular factor is significant. Okay, so in this ANOVA table, can you tell
पूछो
me
किसी का
which
था आप
factor
पूछ
is
कर रहे हो
significant?
आपने जो एक्सपेरिमेंट करा होगा उसमें एरर आया होगा कहीं पे आपकी नेग्लिजेंस की
Come
वजह
on
से
guys,
या
check out the
मिस्टेक
p
एरर होगा
value.
कहीं पे टूल वॉन आउट होगा
Even the a
हैं
value is 0.008, it is greater than 0.005. Sorry, 0.05. Yeah, a is correct. Let me take the pen. Okay, so this value is less than 0.05. So it means this one is significant. So only factor A is significant in this problem. Okay, this is another example. This is completely different problem. Just to show you, I have taken. So if you check out the coefficient of determination here, it is 85. So this is somewhat okay. Okay, not as good as this model. This model is somewhat okay. So this is how you determine the significance of each independent variable. Okay, so in all these problems you have taken only the main effect, that is only one factor at a time. Okay, I'll tell you that also. So when we were solving this problem, we had some graphs, we'll see that one also. So this is the graph for mean. So we had three repetitions, R1, R2 and R3. So this is the graph for mean. So from this graph also we can determine which is most significant factor. Okay. So the first one is pulse current. So for the first level, that is for 5, the value is 700. Okay, this is the output. And for 15, it is about 1000, something like that. Okay, so if you check this graph, you can see that when the pulse current is being changed from a low level to a high level, there is a vast difference in the output. Okay, that's a drastic change in the output. So this factor is very significant. Similarly, in this case also, when I change from a low level to a high level, there is a huge significant change in the output. So that also means we have this is a significant factor. Okay. So in some cases, the graph will look like a simple straight line from like here to here. In in such cases, you can say that that the factor is not significant. Okay, only if you have a drastic change, when we compare the low level value to the high level value, if there is a drastic change, you can say that particular factor is highly significant. So that is how you interpret the main effect plot. Okay, so taken the picture here. So here, can you tell me for what level the micro hardness is high? For what level of pulse current the micro hardness is high?
15.
For what level of pulse current the micro hardness is high?
You can just see the graph and say wherever it
Yeah,
is high.
At third level one.
simply that's it. So this is
Yeah, Lakshmi, you can proceed.
IP3. So at the third level, the micro hardness is high. Similarly, can you tell here in which level the micro hardness is high?
First level.
That's it. P1. Here,
One.
First level.
first level. Here,
Fifth level.
that's it. So from this graph, you can say for the 25 experiments you performed, the optimal combination is third level of IP, first level of ton, first level of pulse
ये होता
time,
है
and fifth level
ऑप्टिमाइजेशन.
of PC. This will give you the maximized micro hardness. Okay, so since this is a maximization problem, I have taken the maximum value. Suppose same thing if you are performing for surface roughness, you have to take the minimal value. Okay, so this is for mean. Similarly, when you are taking for SN ratio, always remember, irrespective of the problem being maximization or minimization, the SN value should be taken to be the larger value. Okay. If your problem is maximization problem, you have to specify larger is better. If it's a minimization problem, smaller is better. But here you should always take the larger value. So can you tell me what is the best level here?
Effect
IP.
participation
So
ratio.
for which level the signal ratio is very high?
3115. Similar master.
Similarly, okay. Remember, so I want to specify here when here the instead of hardness, if I take surface roughness, then the level the first level will be chosen because I'll be choosing the minimal value. But even if I plot the SN ratio for surface roughness, that is the minimal function, I have to take the maximum only. Only here it will be changing as smaller the better. Okay, so the formula will be completely different. For smaller the better, the formula will be completely different. Okay, so signal to noise ratio should be always very high. So this is how you interpret a main effect plot. Yeah. The next one is interaction plot. Okay, so you would have got that also behind here. Okay, somewhere behind. So this is the interaction plot. I will tell you how to read this. The only thing, so here, let me tell you how to read it first. So this is factor A and this is factor B. So interaction between factor A and B is given in this graph. That is when the factor A is at low level 1.5, and if you are varying the factor B from 80 to 120, this is the curve you are getting. Okay, let me repeat again. When your factor A is at low level, that is 1.5, and you are varying, you are keeping it constant 1.5 as constant A. Okay, and then you are varying the B as 80, 100 and 120. This is how it will look. Okay, so what you can infer here is, if the graphs are parallel, if the interaction graphs are parallel, okay, say for example I am getting it parallel like this, then it means there is no interaction effect. So even if you keep the A constant or vary the constant, the AB effect is going to be 0. Okay, if you have a parallel line, then your interaction effect will be 0. So as you can see here, most of them, the lines are parallel. So you can conclude that the interaction effect has, even though there might be some significant main effect, the interaction effect is very, very poor. Okay, so I've closed the graph here. So let me plot the interaction effect and show it to you again. In this case, we can see the difference, because here it will be completely different. So click on Start ANOVA interaction plot. Click on the response. So I'm going to get the plot for mean. Okay, mean is going to be my response. Factor is, I have 4 factors. Yeah. Okay, can you see the difference? See how the interaction plot was here. So it was mostly parallel, right? So the interaction effect was very, very poor here. But for the problem which we are performing in Minitab, you can see that's a very,
ये वाला
very
बंदा
high
तो यही है
interaction effect. So it means while performing the Takuchi analysis, we
फाइनेंस
also
नहीं
have
पता
to
नहीं लेट
include
हो
the
गया आज
interaction factors. Guys,
आएंगे
can you
बस
understand?
एक आप ऊपर जा सकते हैं हरमैन सर की जो लैब है वो सारे
Okay.
बंदे
Okay.
एनसीपी ही
I
काम
think
कर
I'm
रहे
taking lot of time.
हैं दिनेश सर की लैब के पास है
Uh, Dr. Dinesh, is it okay if I carry on?
Yes, ma'am. Yeah, you can proceed.
Important people. So your quarterly
What about the participants? I think I'm taking too much time.
मगर अहनज़ आ तुझे
No, actually, no issues. Like, because if you're, they just want to know all this for running their project as well. Because that's the reason most of them are there. Like, you can proceed, no
the whole
issues.
institute revolves around the dean PA because
Okay, okay, I'll do it. Okay. So I'm going to include the what
सर
I'm saying.
आईडी
Yeah,
नंबर
include the
भेज दीजिए
interaction
दोनों
effects
खड़े
also.
साथ
Let me
साथ
see
बात
how
कर रहे
the
हैं
interaction effect looks. So last time I took only the main effect, that is A, B, C, and D. Now I'm going to consider the interactions effect also. So let me include all those. Okay. Right. So I've taken all the interaction effects. Let me see the analysis. Okay, so plots will be the same. Yeah.
मैं एक पुराना मिनी टैब यूज कर रही हूँ अभी तो लेटेस्ट में अच्छा खासा है
Okay, so the interaction effects have been neglected. I'll tell you why. Okay. Okay, so I can go with ANOVA and I'll show you how the interaction effect will look like. So I'm taking the mean as a response. So initially the model, I'm taking only the 4 factors. So ANOVA general linear model. So I'm taking only the 4 factors. Okay, you can just read it and you have an understanding. Right, so this is what you got in Takuchi analysis also. That is, when I used the main effects, I got values similar to this. Right, now I want, as I was saying, by looking at the interaction graph itself, I can say that there is some significant interaction effect which also has to be considered. Right, so I'm going to now include those interaction effect. Okay, so when you include interaction effect, click on that factor, insert a multiplication sign, then click on another factor. So like this you can include whatever interaction factors you want to get. Okay. Now let us check the results. How does the result look? Is there any p value or f value?
No, ma'am.
I'll show you the difference. Last time we had a p value and f value, but here we don't have anything. Can you tell me why?
कैमरा बेटी था इस कैमरा तो बंद कर दो मैम
Okay, I'll explain you. So please note the difference here. So when I had the only main effect, I had a f and p value. Whereas when I had interaction effect, there wasn't p and f value. It doesn't mean that whenever I include the interaction effect, the f and p value vanishes.
No.
Why it has vanished in this cases, I'll show you that. Because the error factor, the degree of freedom of error has become negative. Okay, I will tell you what is first degree of freedom. So in this problem, the pulse current had 5 factors, right? So degree of freedom is number of levels minus 1. So pulse factor had 5 levels, so 5 minus 1. So each factor had 5 levels, so the degree of freedom is 4. Okay, so in total I have 5 factors with each factor having, 4 factors with each factor having 5 levels. So minus that is 24. So 24 minus 16 is 8. Only when the error is positive, okay, only when the error is positive, you will be getting f and p value. When the error becomes negative or 0, your f and p value vanishes, or it simply in ANOVA it will be shown as some asterisk. Okay, it means what it actually means is you will be getting asterisk. So what actually it means is the number of experiments being performed is inefficient, so number of trial is very less, so in order to predict this interaction effect. Okay, so you're out of 486 experiments, you have performed only 18 experiments. So using these 18 experiments, you are able to determine what are the main effect plot. But even though the interaction effect has significant influence, which you can observe from the interaction plot, you still don't know which combination, that is AB is having effect or AD is having the effect. Okay, you don't just like from this p value it was very clear all those 4 factors had some effect, but here when you're trying to get the interaction effect, the f and p value will vanish. Okay, only when you have sufficient number of experiments. Okay, so here you performed only 25 experiments, so the degree of freedom is 25 minus 1, 24. Only when you have sufficient number of experiments, the error will be positive or greater than 0. Then only you can interpret the f and p value. Okay, if you have insufficient experiments, then your f and p will vanish. Most of the scholars will actually panic when f and p value vanishes and they think they made a mistake. Okay, so the mistake is we have very less number of experiments, so those are not enough to infer the results. So that's why most of the ANOVA, when you are using Takuchi's design of experiment, most of the ANOVA table will have only the main effect plot. If you want to have the interaction effect, then you have to move on with the response surface methodology. Okay, I'll skip this slide because I want to show you more about the PSO and GAMS. Okay, so next we'll move on to response surface methodology. So I've given some introduction. I'm directly moving to the demo, like as in how to do that. Okay, so I'll share the slide. So those are pretty basic. I think you can catch it up. Right, now I'm going to develop a mathematical model that is going to fit this output. So mean is my output, right? So the average of these three. So mean is going to be my output. So I'm going to fit a model that is going to predict this value based on different values of the inputs. Okay, so for that, go to stat, EOE, response surface. You can create a new response surface. Okay, you have a variety of designs. You can do that. Okay, since I already have the model, I'm going to simply define it. Instead of create it, I'm going to simply define it. Okay, so what are the factors? There are totally 4 factors. So click on low high, it will automatically take the low and the high value 5 and 25. So the low value is 5, the high value is 25. So like that it automatically take. Yeah, the another thing is you have to be very clear here. Coded means the value will be 1, 2, 3. Okay, first level, second level, third level, or -1 level, 0th level, first level, like that. So since you put up the value here, click on the uncoded. Make sure you are having this uncoded option. Okay, if you give the actual value of the factors, it should always be in uncoded mode. Okay, click OK. So automatically it takes up the value. Now we can analyze it. DOE, response surface. So previously these options would be grayed out. Now you can analyze. So it will ask you for the response. So I'm taking it mean. So be very careful to click on the uncoded unit, because if you click on coded unit, your entire result will be varied. So terms. So here you can give you all the interaction effects. The response surface method is capable of finding the interaction effect even with the low number of experiments. So I'm simply moving on. Yeah. So this is the result you are getting. So this is the very important thing, because from this only we are going to get the model. So this is the coefficient. Okay. So our model will be MRR is equal to. So let me show you in my PPT. Okay. So this is what you got, right? Coefficient. So this is the first thing. So the micro hardness, it is nothing but the first one is constant
Integration model भी
686.71. The next one is plus
नहीं
60.306.
पहले
So this is taken from the paper. So 306 into IP plus 1.740 into T1. So like this, you can formulate the mathematical model. So this is
बन गया आपका
what we
मॉडल
are
ये आपको डालना
expecting.
पड़ेगा
So now for whatever value of IP, okay, now I can give IP to be 6. For that I didn't perform any experiment. So for whatever value of IP and whatever value of T on, by substituting it, I can determine what is the micro hardness. Okay. And on the right side you can also observe the p value. So this will also give you the significance of the interaction effect and everything. Okay, so here your r square is 90.80. It is well and good. Ignore the remaining values, because remaining value will consider the standard deviation, right? Yeah. So if you check it out, below you have a ANOVA table, but in this ANOVA table there will be only 3 terms: linear, square, interaction. Okay. So if you check out this ANOVA, all 3 are having significant value, because this is less than 0.05. So what it actually means is, the term linear is nothing but the main effect, the consideration of only the factor A, consideration of only factor B, consideration of only factor C. Square is A into A, B into B, okay, the square term. Interaction is AB, AC, AD, etc. So if you check here, the interaction value is 0.158. So the interaction effect is somewhat less, but the square effect is very high. That's why when you check out your mathematical model, you can see all the squares will be present: IP squared, TM squared, P squared, tau square, etc. But the interaction 1, 2, 3, 4, 5. Out of 8 interaction, only 5 interaction values will be there. That is because this interaction effect doesn't have much significant effect. Only the squares are having significant effect. Okay, any doubts? So that's all about mini-tab statistical analysis. Okay, so let's move on. We want to finish it by 12. Okay, so now we have formulated the model.
12
So
बजे तक
I
है
have done only for micro hardness. Similarly, you can do for surface roughness also. So same procedure. Using that, you can find out the you can
Ma'am,
find you can find out the equation.
ma'am,
Yeah.
ma'am, in the design, suppose if no value it is there, suppose no different types of drill bits if we take,
Okay.
Then in the mathematical model, it will give the value of just drill type, no, madam. Then we can't give the value.
Yes, yes, yes. In
Then
such case, yeah, it's a good question. In such case, let me tell you. Say for example, the powder, the type of powder that is vary. Okay, okay. So low, high, I want to give it as coded. So when I give it as coded, what happen is it will get.
Let me kindly mute yourself. It is getting. Let me kindly mute yourself. Sorry, ma'am. Proceed.
Yeah, if it is coded, it will have only numerical values like this: level 1, level 2, level 1, level 2. Okay, so in this case, powder, the say for example, I'm using copper powder and titanium powder. So level 1 is copper powder and level 2 is titanium powder. Then all the execution should be done using this coded data. Okay, if it is coded, okay, it will won't take the values, it will just assume the levels. Okay, and the mathematical model you are getting, it will be integer, either it will be level 1 or level 2. Do you get what I'm saying?
ma'am,
Yeah.
then in that case, if we want to substitute the values of suppose here input current like that, no, we
Mm.
can't substitute the value of power, no, ma'am.
I don't get it. What?
In the mathematical model, suppose
Mm.
if we will get
Everything will
just
be level 1 and 2 only. Okay, in that case you can say all these three factors, that is PC, PD and DC, they are real number. So it will vary from 1 to 2. So if it is 1.5, say for example this level 1 is 10 and level 2 is 100, then 1.5 is, so what is the value between 10 and 100? Say for example 50. Do
yes,
you get
ma'am.
what I'm saying? Mm. If you
Okay,
use coded for one particular input parameter, then everything should be coded. Okay. Only thing you can do is while defining the mathematical model, you can say the first three factors A, B, C, they are real numbers. That is, it can take any value between 1 to 2. That is 1.3, 1.2, 1.4. Okay. So if it is 1.4 means you can correspondingly find out. So level, if 1 is 10 and 2 is 100, then what is 1.5? You can find it easily. But you have to specifically mention this powder. This is an integer value. So it can take either 1 or 2. Okay, that we can do in the mathematical model. I will tell you that. Okay,
okay,
that's why I was very specific. If you have a text or a text as a input value, then you have to go with coded. But if you have a numeric value, then you can use uncoded set. Okay, but if you use coded, all the variables should be in coded format only. It should be 1 or 2 only.
okay, ma'am.
Is it clear? Yeah.
Yes, thank you.
To try out with examples, if you have any doubts, you can get back to me. Okay,
Okay, ma'am.
so this is
Thank you.
the model. So the first one here is the objective will be I'm going to maximize the hardness and minimize the surface roughness. Now I have to write down my constraints. So my constraint is IP is, suppose if you are using the coded value, okay, my IP will be, so there are 5 factors, right? It will be varying from 1 to 5. Okay, if I'm using coded, remember that. If I'm using uncoded, then my IP will be from 5 to 25. The value was given. So you should write the constraints clearly. Okay. At the end, I will also declare IP as a real number and say, for example, the powder, so that is the integer. Then I have to say it belongs to 0 to 1 or 1 to 2. It is an integer number. So like that we have to be very clear. Once we write the constraint clearly, then it will actually the value it will take up will also be according to that. Okay, so this is your model formulated. So till now we have seen Takuchi analysis where the variables can be ranked depending upon their impact on the output. Then we also can determine what is the percentage of contribution of each variable. and we can find out the main effect plot, interaction effect plot, etc. And then using RSM, we can determine the mathematical model to predict the output. Okay, so from the model only we are going to do the optimization, right? So first let me tell you what is the difference between single objective and multi-objective. In case of single objective, there will be only one objective subjected to a set of constraints, similar to what I've seen in the last slide. Whereas in case of multi-objective, there will be more than one constraint, sorry, one objective, which might be conflicting in nature. Okay, for example, I want to minimize my surface roughness, and I also want to maximize my material removal rate. Okay, I have to do this both simultaneously. So this is not possible, because when I want to increase my material removal rate, automatically my workpiece will be having a poor finish. When I want to improve the finish, automatically the material removal rate will be very, very less. So these are conflicting objectives. So in case of these conflicting objectives, there won't be one solution. There won't be one solution. I have to compromise either on the material removal rate side or on the surface roughness. So where the compromise, depending upon where the compromise is made, I'll be having a set of solutions in case of multi-objective optimization. Okay, there won't be one solution, there will be a set of solutions. Okay, those are known as Pareto solution. I'll tell you that in detail. Where in case of single objective, there will be only one solution. Yeah. So this is the example which I solved using GAMS, the material hardness and surface roughness. Okay. So this is the plot which I have done. So this is the material hardness.
Ma'am, one more doubt, I'm sorry.
Yeah, tell me. No issue. Tell me.
Ma'am, in multi-objective, suppose if all the responses should be of minimum only,
Okay.
then also we can call it as a multi-objective, no ma'am?
Sure, sure. Yeah.
Not compulsory, one is maximum, one is
No,
minimum
no,
like that.
no.
Ah,
Both, it can be, yeah, I will tell you that. Okay. Your doubt will be clarified here. Okay, I'll tell
sorry,
you that.
madam.
Yeah, sure. No issue, no issue. Please be more interactive, then only I can also know that someone is listening.
Thank you.
असल
Okay.
कोई सवाल प्रश्न
So I've taken a set of
थोड़ा सुनो तारकम
12 solutions.
गाना से
My objective here is I want to maximize the hardness, right? So the maximum value is 112.164,
optimization
right? So that will be here 112.164. And I also want to minimize my surface roughness, that will be 0.84. So if I plot it, so 1 and the 0.84 means
Yosi
this is
Harisham
my
Parnam
ideal
Sabu
solution,
Mini
right?
tab
So this
sorry
is 0.84, this is 1001.
Maximum can Paknaman multi
22.
objective
Okay, so this is my ideal solution, but this cannot be achieved because when I try to
YouTube पे भी कुछ
maximize
खाली
my
अब साथ साथ जी
material, maximize my hardness, obviously my surface
कुछ
roughness
सही है
will
कुछ नहीं है सही
increase, right? When I try to reduce my surface roughness, obviously my hardness will also reduce. Okay, so I cannot get a single solution where both hardness is maximized and surface roughness is minimized. Okay, so I will be having a compromise. So if you look at this first solution, okay, here I have received a good surface roughness, so 0.8, so that is very, very low value. But if you compare the image, okay, when the surface roughness is less, you can see that I had compromised my hardness. Okay, so like this I will be getting a set of solution where there will be some compromise. Okay, depending upon the decision maker's attitude. So decision maker might be having an attitude where he's very, very very picky about roughness. He want to have a very, very good surface finish. So what he will do, he will either choose this solution. Okay, some other decision maker will want to have somewhat good finish but very, very high hardness. So what he will do, he will pick up this solution. Okay, so this Pareto front is obtained in such a way that this material, for example, this hardness cannot be improved further without reducing this surface roughness. Okay, so what I'm trying to do is Pareto solutions are those where uh, one objective cannot be improved further without reducing the second objective. Okay, so if I want to have better surface roughness, so here see, I want to have a reduced surface roughness. So if I reduce this one, automatically my uh, material, sorry, my hardness will also come down. So if I compromise on one solution, then only I can get a better one. So in case of multi-objective optimization, you won't be getting one solution, you will be getting a set of solutions known as Pareto solution. Then depending upon the decision maker's attitude, he can choose any one solution. Okay. So this is how the Pareto front will look. So this, so if your problem is
Vaccination हो
the
गई
first objective is minimization
यार
problem, and
छोड़
if your second objective is
यही
minimization, both are minimization means
तो
your
मिनिमाइज की
Pareto front will look like this. So this is how it will be distributed. If one is minimization and another is maximization, it will be distributed like this. If one is, the first one is maximization and second one is minimization, the curvature will look like this. Okay. So just by looking at the curvature, you can say whether your algorithm has worked or whether your optimization has worked or not. Okay. So by looking at this curve, can you tell me what type of problem this is? You can compare. You can compare and tell. So what type of optimization problem is this? You can look at this curve and tell. So which shape this one fit?
खींचे
Among these four curves, which
12
shape?
Max minimum,
Yeah,
ma'am.
maximum. So I'm maximizing the hardness and minimizing the surface
शेप
roughness.
पार्टी देनी
So once
पड़ेगी
you solve the problem, and if your
ये लगा हुआ
Pareto front look like this, then you can be 100% confident that you have done a correct job. Okay, if it is a maximization minimization problem and your curvature is like this, then you have made some mistake. Okay, you can rectify like that. Okay, so I wanted to explain these in detail, but I have a very poor time management, I think. So this is actually a step-by-step procedure. So this is the Pareto front you have got. So as I was saying, your hardness is high here, and your surface roughness is low here. So this is your ideal point. Okay, so one way to choose the best solution is, so this is your Pareto solution. One way to choose your best solution is calculate the equilibrium distance between the ideal solution. So this is cannot be achieved. Okay, you cannot achieve, you cannot have a combination of input parameters where both the two objectives are maximized or minimized. Okay, so you can determine the distance between the ideal solution and the Pareto solution, and whichever solution will have minimal distance, so that solution can be selected. Okay, that is one way of choosing. Choosing a solution among the Pareto front, it completely depends on the decision maker. Okay, yeah. So as I explained before, there are classical and Pareto methods. So the epsilon constraint is what we are going to see under classical, and in case of population based, we'll be seeing PSO. Okay. Yeah, let me demonstrate how to do a single objective optimization using GAMS. Luckily, I have written the codes and everything. Actually, I wanted to write the code in front of you. Okay. So GAMS is actually, this is not open source, but it provides a student version where you can solve problems with maximum 10 variables and 10 equations. Actually did my entire PhD in this. So if you don't have if your problem had more than the 10 variables and more than 10 equations, you can use another online solver, which I'll show you how to use that. So using that you can solve it. Okay. Coding in GAMS is very simple. It's not like MATLAB. It's very simple. So if you are using for machining purpose, that is, if you are going to model a mathematical model and optimize here, GAMS is the best thing. Okay, I'll show you. So this is our model. Right, we have, first I'm doing a single objective, so first I'm going to model only this. So I have an objective function and 4 constraints. Okay, I will be giving values for each input parameters, right? So first you have to
मतलब
define what are the
कैसे पैठना हो
values, what are the unknowns you are going to find. Okay, the first one is my
10
objective
बजे के
function.
ये
Okay, so this
सेशन
is
खत्म
nothing but your micro hardness.
सौ
So
साढ़े का गसन तो सुबह
that is
थोड़ा
defined
एक्सटेंड
as a
पाने सुबह
variable.
हटाएंगे
Then I have four input parameters, right? X1, X2, X3, X4. That is the input current, power duty cycle, etc. These are independent variable. Okay. Opt CR means I want exact solution. When it becomes zero means I don't want an approximate solution. I want an exact solution, right? Then I'm defining the model under equations. So in first equation, I'm writing the uh,
क्यों
this model we developed.
नोट के
MRR
चलते
is equal to 686.71 plus 60.36 into IP. Okay, here I will referred IP as X1. Okay, 0.6658 into, I think I will use the same model. Let me check it out. Yeah, I've taken the surface roughness. Okay, so 0.6658 plus 0.2129. Okay, so return it exactly. So if you want to use multiplication, use this asterisk sign. So x1, x2, x3, etc. Make sure you have defined x1, x2, x3. Okay, it should be defined under variable. Okay, so the x1 value varies between 5 and 25. So less than inequality is given as equal to L equal to. So x1 is less than 25 or x1 is greater than 5. Okay, so like that I have defined for all the four variables. I know I'm going fast, but I just want to show the demo so that you can get the concept. It's very simple. So first define the variables you are going to use, then start formulating the equation. So whatever we got from response surface methodology, I'm simply writing it in the equation format. Be clear with the constraints. Okay. Suppose if you want your variable to be an integer variable, as I said in case of uh, the coolant type or lubricant type, okay, then you can define x1 and x2 as an integer variable. Okay, in that case it will take only a value as 1, 2 or 3. Okay, if I simply declare as variable, it will be a real number, that is 1.5, 1.3, etc. Okay, right? Then model example, all what I'm trying to do is I'm naming this model as example. Now I'm going to solve this example. So my function is surface roughness, so I'm minimizing. Suppose if you want to maximize, simply change this as maximizing problem. Okay, so this is a minimization problem. So minimizing. Okay, my objective function is z. Okay, you have to specify what type of problem is this. Okay, if your objective function or constraint doesn't have any non-linearity, that is it has only one variable, so if there is only x1, x2 and x3, then that is a linear programming. But I have here x1 square, x1, x2, etc. So this becomes a non-linear programming, so I'm choosing NLP. Okay, so display x1 dot l. Dot l means optimal level. Okay, so I want this problem to be solved and the optimal value of x1, x2, x3, x4 and the z is needed. Okay, so let me run it.
थोड़ी
So click
मिनिमाइज
here,
की
it
तो
will automatically
ट्रांसफर
run.
ये सुकर ऑन है बस बस आज फिर थोड़ा स्क्रीन इतना काम है स्क्रीन फ्री को नहीं
Yeah, 1 second.
बस जज़ाकल्लाह
The solver has been wrongly selected. Let me choose a different solver. So if you want to change the type of solver, go with options, solver. Okay, I'm using a student version, so I don't have a license, so everything will be a demo. See, some versions will be available in full. Okay, Baron is the best solver for solving the NLP problem, so I'm going to choose Baron for NLP problem. If you click it, so it means that this Baron solver will be used for solving this problem. Okay.
कोई क्या फाइल
It has been solved. Okay. So only when you get this report summary, non-optimality 0. So this is optimal solution. If it is 0 means non-optimality is 0. So this is optimal, feasible, bounded without any error. Okay. So my solution is
Into problem here. Well rested.
558.3.296. Okay. So if you want
Response.
x4 to be an integer, you can separately define as integer variable. Okay. My output is
Time से मैं ये तो
0.804.
टाइम लगा टाइम
Okay,
को
so the minimized surface
1000
roughness is
टाइम चला गया
0.804 and these are the
हाँ
corresponding levels.
हम्म
Okay,
एक
I wanted
इक्कीस
to
लाइन में
teach
सीएमसी
you
से ऐसी
what is
प्रॉब्लम
PSO and all, but
ठीक
because
नहीं
of time constraint, I'm actually directly moving on to PSO. Okay, same single objective problem. Let me solve with PSO and show you the solution. Okay. So PSO code, everything is available in online. The thing is, you should have some very basic knowledge to uh, modify the code so that your problem is fitted. Okay. So everything I had never coded. I'm familiar with GAMS. Okay, but MATLAB I'm actually very poor in coding. So but I know how to fit my problem to the existing coding. Okay, I'll show you that.
मॉप तो
Since all three softwares are being open, it's hanging a lot. Okay, I'll tell you how to run a multi-objective optimization. Okay, the same problem. Okay, whatever problem which we have seen here, the same problem. So in addition to the surface roughness, I have included the micro hardness. Okay, same thing. I have included an extra equation. Okay, till this I think everyone can write, right? After this, I have used an augmented epsilon constraint technique to do the multiple objective multi optimization. So this part, this is completely taken from internet. Okay, since I'm been working in GAMS for past 5 years, I know how to read this.
कैसे लिखो
But even if you don't know how to read it, you can simply copy it from the internet. Okay, it's available. If you click on it, you can see it. Okay, the GAMS will provide those kinds of versions. Everything is not responding. So completely copy it and paste it. The only thing is, in the model, make sure it is all NLP. Okay, instead of linear programming or mixed integer programming, since our model is NLP, wherever there is a solve option, change it to NLP. Okay, and this code is written for maximizing objective. Okay, so what we have to do is, in the beginning itself we have to define whether we are going to maximize or minimize. If you are going to maximize, the particular objective will be assigned +1. Okay, this is all available in the code itself. If it is going to be minimization, it will be assigned -1. Other than that, there will be no changes. Okay, so till this you can copy it, and these are all from the internet. You have the GAMS coding for augmented epsilon constraint. Only thing is, wherever there is a solve option, change to NLP. Okay, let me run it this and see.
इंग्लिश में रिकॉर्डिंग चला ये रिकॉर्ड चला ठीक है की कोड इसमें यही विंडो है
Okay, so you'll be getting an option no license found because our problem has 11 11 rows means 11 equations, 7 columns means 7 variables. So it's exceeding our license. So this is what I was saying. So if your problem is small, you can solve it with Barrow. If your problem is large, no issue. What you have to do is, yeah, type Neos solver. Okay, Neos solver. Okay, I've already solved. Okay, I'll show you how to do that. Type Neos solver in Google. Okay, you'll be getting the home page. So they provide all the solvers free without any cost. Okay, all you have to do is write your model in GAMS, then import it to here and run it so that you will get the solution. Okay, it's free of cost. So at the end of my PhD, I used completely this only because I didn't have the license. So all the programs were run here only. So I have the Baron license here. So I can give two types of input. AMPL is similar to GAMS. This is another mathematical programming language. It stands for another mathematical programming language. GAMS stands for General Algebraic Modeling System. So click on GAMS. So you'll be taken to this page. So you can upload the GAMS model. So upload it. Let me choose the file. Yeah. So this is my GAMS MO. Open. Type in your mail ID because your result will be sent to mail. If your program will take too much of time to run. Since our model is very small, we'll be instantly getting the result. So your program has been submitted. So it's waiting for result. So job completed, waiting for result. Right? So you got the entire result. Okay, so I have 11 Pareto optimal solutions. So the code is written in such a way that I need 11 Pareto optimal solution. Okay, so let me go to the bottom. I will show you one solution for an example. So yeah, the minimized surface roughness. Surface roughness is 0.804, and since surface roughness is minimized, the hardness value will also be less. So that is 729.065. So the corresponding values of the input parameters is also given. Okay. So I showed you the example right in case here. I showed you a Pareto curve, right? So that was obtained from this method only. So this was the solution I got. So I gave 11, I specified that I needed 11 points. So 11 Pareto solutions. So this is the solution which I got. So once you get the solution, you can plot that in, write it here and plot it using a Excel. Okay, so we have seen single objective optimization and multi-objective optimization in GAMS. Okay, so once you form the mathematical model, you can simply solve it in GAMS. Okay, so GAMS is highly studied in supply chain management and medical approaches. In case of machining operations, if you Google and if you search in Web of Science, you will find very less paper in GAMS. But the GAMS is very easy. So if you can propose a model and solve it in GAMS, the probability of your paper getting acceptance is very high. Okay, because very few works,
Very good.
less than 15 works, but it is so simple, as I was showing. Less than 15 or 20 works alone will be done in machining operations are done in GAMS. Mostly
So
people are
next we'll go for this one, ma'am, for publishing.
yeah, sure. Let me show the PSO. I'll finish off in 10 minutes, I promise.
Great.
Okay, so again, as I was saying, I took this code from the internet only. So I'll show how to solve PSO in how to solve the single objective and multi-objective using PSO. I'll share my slides. I will explain in detail what is PSO, what is meta heuristics, and everything. Because of the time constraints, I have to rush it up. Yeah. So single objective. So if you download from internet, all these four files will be obtained.
बस लागे क्या În ce asta? Cartoon क्या है जी? Am peras बनाऊँ? हम्म? Class की घूमती? Am peras मजाक कैसे बनाऊँ? Parent क्या कर रहा है? ज़हूर? ज़हूर in cartoon? She should down.
Yeah, finally.
Yeah, Imran Khan.
I think okay, I'll want to show the results of GAMS and compare to this. So these are the four files that are available with a single objective
तुम्हारी
PSO.
select
Okay.
हमारी
So if you move on to the main file, this is where the problem is being defined.
रास्ता
Okay.
तुझे अब मालूम
Yeah.
ऊपर
So
देखो
here, this is where we are going to fit our own problem. Okay. So here, this is the place where the problem is being defined. Okay. If you are getting the codes from the internet, most of them they will be very very clearly mentioning what a particular code is for. They will be giving comments and everything. So this is where you are going to define the problem. So my problem is a cost function. So what it means is this is completely a minimization problem. So if your problem is maximization, make sure you multiply with a minus. So this is a problem function. It is rewritten to sphere. So my problem is defined in sphere. So I'm going to sphere. Okay. So first 0.6658. I think this is yeah, 6658 is surface roughness. So this is the I'm trying to minimize it. So what I have to do is I have to write my objective function here. You don't need to do anything else. Just simply copy your objective function in this file. Already there will be function z is equal to sphere and everything. Only thing you have to do is copy it. Okay. In case of GAMS, you will be defining x1 like this. Simply x1. But here you have to indicate within a bracket. So all you have to do is put in your objective function here. Okay, then save it. If you don't save it, there will be an asterisk symbol and it won't run. Okay, save it. Go back to your problem. Now it is asking how many number of variables are there. So there are four variables. The next one is problem dot var minimum. Okay, it is asking what is the lowest value of each variable. So the first variable had a lowest value of 5. Second variable lowest value was also 5, 8 and 0. Okay, the maximum value is 25, 100, 40 and 8. Okay, so in most of the code what they will do is they won't mention as an array like this, because most of the mathematical model will be done in coded form. So mostly it will be a 0 and 1. Okay. So if you have like this, please make sure to change it to the array. Okay. Only if you, because if whatever code you download from the internet, it will be having only 1 and 0 as minimum and maximum, because that model is being done for coded response surface methodology. If you are having uncoded, then you have to compulsorily mention what is the minimum value of each variable and what is the maximum value of each variable. Okay, that's it. Try running any one of it.
Don't try to go like smart is going man.
Okay, if you get busy, it means it's running.
बहुत सारी चीजें हैं
Okay, so PSO there will be a population size and that will be some 100,000 trials. Okay, so if you want to check out the solution,
सारी क्वांटिटी
okay, there should be a workspace. We read and show. It's still running. The system is getting so laggy behind. Just give me a minute, I'll rerun. So this is the minimum surface roughness which we got in GAMS also if we compare the solution. There is single objective. It's running. Yeah, it has run. Okay, yes. So we got the solution. So for single objective, there is no need for plotting. So if you want to know what is your optimal solution, click on here. If you click on the cell here, you will be getting what is the best surface roughness and what are the possible combinations of input variables for which this particular point 8042 is obtained. Just as in GAMS here, just as in GAMS here, you will be getting what are the x1 value, x2 value, x3 value, etc. Okay, mine is getting lagged behind, so sorry for that. I'll show in multi-objective optimization. So I hope you got some understanding here. So all you have to do is you just have to fit your problem into the existing code. Laggy. Let me close everything and see. Okay, I will show you the same thing with the multi-objective problem. Bear with me, kindly bear with me.
Okay. क्या है system one second. Not responding, not responding, not responding.
Let me close this off and show you. So that is the last demonstration. With that, I'll close off the session.
Ma'am आप रहने दो.
Okay, I think some lagging issue with my thing. Okay, so if you run the PSO, just like we installed that z is equal to 1 function, right? So similarly, we'll be adding two functions. That is for one for micro hardness as well as for surface roughness. And then if we execute it, we'll be getting the graph like this. We'll be getting the Pareto curve. Okay, and on the right side, we can also see what are the different combinations of these x1, x2, and x3 for which the particular parameter has been obtained. Okay, so mine is lagging behind, so very sorry for this. Since all the three softwares have been opened, it's lagging this much. Just wanted to show you that one.
इंस्टाग्राम में भेजी
Dr. Dinesh, I think my system has hanged out.
दिनेश सर हैं हाँ दिनेश सर तो हैं ये कर कैंसिल तो ये लाग भी या इसको फोल्डर स्पेशल आइकन
I think I will close my session here because it's not working. So that is the last demo I wanted to show. So I'll share my codes. So if you run it and see, so that this is the procedure. You just have to fit in that objective function in the sphere or cost function. Okay, z1, z2. Then you have to change the variables. That is the maximum and minimum value of the variables. And if you run the code, it will give you the Pareto curve as well as for what particular combination of the input variables you want it. It will be clearly shown. Adinesh, over to you.
Thank you, ma'am. Thank you very much for the wonderful session. Like it was almost more than 1.5 to 2 hours. It has been. Hope the participant got too many inputs from this. Like most of them were interactive and they were asking too many questions as well. Hope the software, whatever you are into, either it is a Minitab, MATLAB, or GAM, like which I'm even seeing it for the first time. Participants, like if you have any queries as well, you can put it to ma'am or you can even mail it to me. Like we work together, so we can help you out in some passes what you want. Thank you so much for spending your valuable time and guiding our students for their project as well as on
ना ना
optimization techniques,
चलो
ma'am. Thank you so
लोगों ने
much.
भी ना अच्छा नहीं स्टेशन क्या है
Thank you for this opportunity. And my contact detail is with Dinesh. If you
लक्ष्मी
have any
लक्ष्मी क्या बात
queries
कर
or if you want to my
लक्ष्मी बात
codes,
करने
then
वाली
you can contact them. I will share it. Thank you. Thank you. Thank you for this
Thank you.
opportunity.
Thank you.
ठीक